Good morning, ladies and gentlemen. And so today we will be trying to understand the the question number B from today's contest round 1092. Yeah, division two. So let's read the question. The question name is THU Packing Puzzle. There are three types of 2D blocks: T-shaped, H-shaped, and U-shaped. Their exact shapes are shown in the figure below. T, H, U. One thing which you guys should notice is that all of these uh, three characters or three shapes require 3 cross 3 grid. Yeah, you are given three non-negative integers ct, ch, and cu representing the numbers of T-shaped, H-shaped, and U-shaped blocks respectively. Your task is to pack ct plus ch plus cu blocks into an n cross 3 grid following these rules. So yeah, one thing which is important is that uh, let me draw it. Yeah, so the grid somewhat looks like this, and yeah, so yeah, so this is n and this is 3. And according to our observation, as we have seen that each and every character or each and every shape requires exactly 3 cross 3 grid. So you can place T like this, then you can place U like this, then you can place H like this. Yeah, this is one of our observation. But let's read the rules. Let's read what the rules are. So the rule number 1 is every block must be placed entirely inside the grid. No two blocks may overlap. That is, no unit cell can be covered by more than one block. Now, what does this mean? They can share a border. As you can see, um, U and T are sharing the same border, but this cell is covered only by U. So a particular, column, or a particular x comma y position should be occupied by only one of the shapes. Blocks can be rotated by any multiple of 90 degrees. So you can write T like this or like this, like this, like this. Yeah. Basically, uh, yeah, you get the point. You have to find the minimal possible value of n for such a packing which exists. Okay. So I would like to ask one simple question. Forget about the minimal value of n. If I ask you, let's call this CT, CH, and CU as X, Y, Z. Yeah. So let's say there are X, Y, and Z. So what's the most naive arrangement which you can think of? And you may say, let's say there is one uh, one T, one H, and one U. So what you can think of is T, H, and U. This is of size 3, this is of length 3, this is of length 3. And we have given that this is of length 3 as well. So one thing which you can notice is that the most naive um, combination or the most naive arrangement shall be x plus y, uh, just a second, yeah, x plus y plus z into 3. As you can see, 1 plus 1 plus 1 into 3 is equals to 9. And indeed, yeah, the most naive arrangement um, will be of length 9. So yeah, I have made I have just broken this problem into the simplest components, and I have made many mistakes. As you can see over here, I have submitted this question plenty of times, and yeah, so let me take you through the mistakes which I made. And yeah, so one rule which I was thinking of was this: blocks can be rotated by any multiple of 90. So the most obvious two shapes which I could think of were T and U. And yeah, mind you, the answer for this test case is 7, as it is given over here. Yeah, 1 plus 1, yeah, 1, 1, 1. The answer is actually 7. So I started to wonder, how can I actually save up some space? And the answer lies in these two shapes, T and U. I can write T like this, uh, rotate U um, by 270 degrees, and write H as it is. So I need this is of length 3, and as you can see, this this portion of T, which is of size 3, is actually being inserted in U, which is also of size 2. So actually, this is only of size 1. So the complete length of T and U combined is 4. So yeah, I decided that we should pair T and U such that the resultant or the answer, or the naive it reduces the naive answer by 2. As you can see that I can pair T and U in this problem, and so 9, which is a naive answer, minus 2 is actually 7. So yeah, uh, this is one of the conditions which I can think of, combining T and U, and the result of this combination is actually reduction in the naive answer by 2. Yeah, that was my strategy. But then I started thinking, you know I should check out each and every combination. So what I did was, as I guess you can see somewhere over here, yeah, what I did was, I tried, you know I have to select two shapes out of these three, and the total selections can be 3. So how much space can be saved by combining T and U? And the answer is 2. How much space can be saved by combining T and H? And the answer is 1. Illustration is given over here. As you can see, normally we would have placed our H, a, uh, a row below, but as you can see, the tip of T is being inserted in H, so we are saving space, which is worth which is worth 1. We are saving 1 row. And yeah, that is important because our final um, final problem is reducing or minimizing the possible value of n. So yeah, I imagined how can I save space using a combination of H and U. I couldn't think of any, so the answer is 0. And yeah, one more thing is that you can save some space using two T's by arranging these T's as one T is as it is, and one T is being flipped in the vertical direction, no, in the horizontal direction. So yeah, this is of size 3, this is of size 3, there's intersection of size 1. So yeah, we are saving one row. Yeah, and yeah, this is what I had naively done. I couldn't think of, yeah, this is the next step which I was thinking. I couldn't think of any other way of saving some space. So what my initial solution was, first of all, T is important. Why T is important? Because T is being coupled with U and H both, and T itself couples with itself. Um, so T is important because T is helping us save some space. So what I initially did was, my first solution was I should pair all the T's with all the U's, and now you may ask, why am I beginning with U? And the simple answer is because combination of one T and one U reduces the space by 2. But the combination of one T and one H reduces the combination by only 1. And same goes for one T and yet another T. So yeah, but I fail to realize that this is not the optimal solution. Now you may ask why? Because as you can see over here, I can insert two T's in a single H. Yeah. So if I combine one H and two T, I can save actually two space. Why? Because I'm spacing one space over here and I'm saving one space over here. So yeah, uh, I can show you my code as well. Just a second. Yeah, wrong answer, wrong answer on pretest 2. So what I was doing, yeah. Uh, First of all, I am calculating the naive answer. Then I am calculating the reduction. So pairing T with U. So a minimum of CT comma CU, and as the combination helps us save space by 2, so into 2, and reducing the respective values of CU and CT. Then I'm pairing T with T itself, and there would be after pairing there would be either a single T or zero T's, and I would try to pair this T if any with H if any, and then I would output the answer. But this is clearly not the correct or the most optimal way. So I was in a panic initially, and uh, I submitted the similar solution with the same logic twice, and it was of no use. So I wondered, how can I save more space? So I approached this thing, that we can save H. Uh, we can save more space by inserting two T's in a single H. Now this is remarkable because indeed wasting some space. Let's say for the test case, just a second. Let's say for the test case, 5, 1, um, 2. Not 2, I guess. Yeah. So actually, what I can do is I can uh, pair uh, uh, two H and two U, two T and two U, and minus 2 into 2. This will be the total reduction. As you can see, I have 3 T, 1 H, and 0 U. As of now, I'm trying to combine all of these in order to reduce some space. And as you can see, I should have combined this H. I should write H like this with the 2T so that I can save more space. So yeah, I realized this, and after that, actually, I was also one thing which I would like to ask is we shouldn't pair two T's. Now you may ask why? Because let's say there are four T's. You can arrange these T's like this. So as you can see that there are two pairs of T's, but the actual space saved is actually n minus 1, or let's say k minus 1 if there are kt's remaining, if it consists of k. Now you may ask why? Because these two combination reduces space by 1, these two combination reduces space by 1, these two combination reduces space by 1, and as you can see that there are uh, uh, the intersection point, that there are k minus 1 intersection points, not intersection points, but you know what I mean, k minus 1 sharing edges. So you can reduce the space by k minus 1. Yeah. So now I had one problem, and the problem was, for one thing which I should do always is that I should pair T and U first. And if there's some T remaining, then I would like to decide if I should, pair these T itself and pair these T's itself, or, I should pair two T's with a single H and move on. So I was actually confused, but I realized that whenever I'm combining two T's, this is just my pure intuition. Um, I realized that 1, 2, 3, 4, 5. There are 5 cells remaining. You know, so the space wasted in while combining two T's is actually 5. But while combining two T and a single H, uh, I felt that to be honest, yeah, I don't think it doesn't make any difference, right? Yeah, but this was my explanation to myself when I was trying to solve the problem. As you can see, you can fit one more T over here, so the total number of wasted cells is actually 4. So what I decided to do is, first of all, I would begin by pairing T with U. So yeah, answer minus minimum of CT comma CU, uh, yeah, into 2. If if the values of CT and CU are, let's say, 4 comma 3, then how many pairs can we make? And the answer is obviously 3. So we are reducing 3 into 2 from our answer. I'm recording pairs, and yeah, how many pairs did we make? 3. And I'm reducing 3 or pairs from CU and CT respectively, as they have been used. So my second step was actually combining T with H, as I tried to explain using this figure. And the that I can say, I guess it doesn't matter, the order doesn't matter if the order for combination of multiple T's and two T's in a single H doesn't matter, but I decided to go with this approach. Yeah, so I'm combining two T's with a single H. So as you can see, uh, answer minus minimum of CT by 2L. Now why by 2? Because we are using in a single set, or in a single combination there are two T's. So CT by 2 comma CH into 1. Now why into 2? Because as I have explained over here, we are actually saving two space by combining two T and a single H. And we are reducing the respective amounts of T and H respectively. Now you may ask, why did I write this? Because let's say there is some condition. I can't think of any condition, but I have just written it. Uh, for safety reasons, let's say I have been left with a single T and a single H. So I can't pair this T with any other T because none other T exists. So the most obvious thing which I can do is, if CT is equal to 1, if now CT is equal to 1, what do I mean by CT? Not the actual CT which is being in the test, which is being given in the test case, but the CT which is remaining. As you know, as I have shown you, that we are consuming T's all along. So yeah, uh, if I try to represent this T as it is, so what will be the actual space saved? So here K is actually equal to 1. So the space saved is equal to K minus 1, which is equal to 0. And we are not maximizing our saving. So we should combine the T and H respectively, such that this combination saves one space. Yeah. And even after all of this consumption, if there's some T remaining, then I we can, let's say, as I have explained, if there are KTs remaining at the end, we can arrange these KTs as, in this order, and the saving would be K minus 1. So yeah, maximum of 0, comma CT minus 1. Why I have written this condition of maximum? Because let's say CT is actually 0 in this condition. So we would be actually increasing our answer by 1. Which shouldn't be the case, because answer minus of minus 1 equal to answer plus 1 equal to answer, yeah, in incrementing our answer by 1, which is not true. So a maximum of 0 comma CT minus 1. And yeah, I hope that this approach indeed gets got an AC. Let me show you. Yeah, I have written the exact same code over here, and as you can see, I have got an AC. So yeah, uh, this problem actually was pretty frustrating for me, and I hope that I satisfied your curiosity. I satisfied, all the doubts which you had in your mind during the contest. So yeah, that is it. This was pretty interesting question. I enjoyed this question a lot, and yeah, thank you.